So organic reaction mechanism. So fundamental concepts of organic reaction mechanism. So in this case, first one, bond cleavage in covalent bond. Bond cleavage in covalent bond. So bond cleavage in covalent bond. There are two types in this. One is homolytic cleavage. So another one is heterolytic cleavage. So homolytic cleavage means the bond cleavage takes place, okay, such a way that each atom takes away its own electron of shared pair. Is called homolytic, and the phenomena is called homolysis. The phenomena is called as homolytic. So when you take CH3 example, single bond CH3. So in presence of light or heat, that gives out, see this, each bond contains two electrons. So this electron shifted to this CH3 and this electron shifted to this CH3. It become CH3 free radical. So this is methyl free radical. This become methyl free radical. So this is what? Ethane. Second example, if we take CH3 single bond NH2. So in presence of light, so this bond contains two electrons. So this electron shifted to nitrogen and this electron shifted to CH3. It becomes CH3 free radical plus NH2 free radical. So if it is one dot present means it is free radical. It is methyl free radical and amine free radical. So next one, heterolytic cleavage. So heterolytic cleavage. So in heterolytic cleavage, example AB is undergoing heterolytic cleavage or heterolysis. So both the electrons takes by one atom. So that time one atom become positive and another atom become negative. Okay, this is possibilities One more possibility is A can take both the electrons and A become negative and B become positive. So these are the possibilities. So that time there are two ions possible. One is cation possible. Second one carbon ion possible. Carbocation and carbon ion. Carbocation means carbon with positive charge. Carbon ion means carbon with negative charge. Example, if you take example, say CH3 and Cl. So when it undergoing heterolytic cleavage between carbon and Cl. So which one has a more electronegative element? So Cl is more electronegative element. So this both the electrons shifted to Cl and the CH3 become positive and the Cl become negative. So this we called as carbocation. Carbocation. Then what is the stability order? Stability order of carbocation, that is CH3 plus, next CH3 CH2 plus, next CH3 CH plus and CH2. This is primary, this is secondary, and here tertiary. This is tertiary, like this. So stability order, primary carbocation is more stable. So one minute. This is all. So it is opposite actually. So tertiary is more stable than secondary. Secondary is more stable than primary because of positive inductive effect. Because of positive inductive effect. So reason is positive inductive effect. Positive inductive. What is positive inductive effect means? The CH3 gives out electrons to carbocation like this. So this alkyl groups gives out electrons to this carbocation. So that's why it is positive inductive effect and more stable. So next topic, we can take example C. If benzene ring with carbocations also we have to check. It is one benzene ring with carbocation and one CH3 group. And here one CH3 and CH3 carbocation. Between these two, which one has more stable carbocation? Both are secondary only. This is secondary, this is also secondary. But in this case, resonance structure possible. So here only positive inductive effect. So resonance effect is more stable. So that means resonance effect is more stronger than inductive effect. So first prior is equal to this resonance effect. Here inductive effect also is there, but both inductive effect and resonance effect is there. Here only inductive effect is there. So this is more stable compared to this one. Okay, so this type of questions also you can expect. See example, if you take C6H5 carbocation and C6H5 and here C6H5 and here positive charge. When you take C6H5 and CH and C6H5 and here one CH3 present means make it this is C plus. So in this case, here this electron positive inductive effect, here resonance effect, and here resonance effect. Here three resonance effect. One, two, three. All this benzene group, so more resonance effect present. So this is more stable than this one. We have to check how many benzene ring is connected to carbocation. So that is the stability order. When come to carboanion, example will take say this one. Take expansion. When you take carbanion. So in this carbanion, CH3 is connected to Z. Z is metal. Z is metal. So that time between carbon and metal, which one is more electronegative? Carbon is more electronegative. That both the electrons shifted to carbon and Z become positive. That Z become positive. So this is carbanion. This is carbanion. So what is the stability order? So in this stability order, CH3 minus this. So now methyl anion is more stable than primary, next secondary and tertiary. So this is the odd because this carbon already contains a negative charge. This methyl groups also donating electrons. So stability decreases. So stability decreases. So this is about carbocation and carbanion. So next we'll start reagents. Next one. So reagents. So when you take reagents, the species or compound which attack on a substrate molecule, okay, and bring about a chemical change are called a reagent. Okay. So example we call as electrophiles and nucleophiles. There are two reagents we called as electrophiles and nucleophiles. Electrophiles and nucleophiles. So what is electrophile means? The electrophiles means that is electron deficient species. So electron deficient species. Generally, we are writing electrophile is E plus. This is electron deficient species. Electron deficient species is generally we are writing E plus. E plus. All positive charged ions comes under electrophiles. There are two types. One is a positive charged electrophiles and a neutral electrophiles. So positive charge means all the positive ions comes under this. So neutral means, so example BH3 and ZnCl2 and AlX3 and FeX3. So all this comes under neutral electrophile. So neutral electrophile. So next, under aluminum, yes. So nucleophiles means is generally denoted as Nu minus. Nucleophile, there are two types. One is so negative nucleophiles. So negative nucleophiles and neutral nucleophiles. So negative nucleophiles means so negative, all negative charge. OH minus, Br minus, Cl minus. So neutral means example like oxygen compounds and nitrogen compounds. Because this oxygen has two lone pair of electrons, nitrogen has one lone pair of electrons, and ammonia and R2NH and R3N. So all this comes under neutral nucleophile. There is no charge, but it acts as a nucleophile because this one has lone pair of electrons. So this is about the reagents. So next topic, amphiphiles. We'll do that amphiphiles also. So amphiphiles means it is both. It acts as electrophiles and nucleophiles. Example C double bond O. So it has both positive charge and negative charge. O minus and this is plus. When electron shifted to oxygen, it become carbon is positive and oxygen is negative. So both electrophile and nucleophilic center present that we call as amphiphiles. The next topic will start in reagent reaction intermediate will start in next class.